The Oort Cloud, the invisible icy shell at the edge of our solar system. Try to imagine our solar system, the place where the blazing sun sits at the center, orbited by the blue-green Earth and a host of other planets, is actually encased in a colossal, invisible shell. It's not made of steel or stone, but is pieced together from billions of ancient icy fragments, located so far away that if you were to measure its length using light, it would take you a staggering 1.5 light years to traverse it entirely. This sounds like a script from a science fiction movie, but it is the prevailing hypothesis regarding the Oort Cloud, the extremely remote boundary of the solar system. Not only is it thought to be the birthplace of the comets that suddenly appear in the night sky, but it may also hold clues about how life formed on Earth. So, why do scientists call it the invisible wall? And if no one has ever directly seen it, how do we know it exists? The solar system is far more complex than we imagine. When we were young, most of us were taught that the solar system consists of the Sun in the middle, surrounded by 8 planets orbiting in neat, orderly paths. While seemingly tidy, the reality is far more intricate. Besides the planets, the space around the Sun is teeming with countless debris, ranging from rocks the size of your hand to icy masses as large as mountains. It is these fragments that create the vast and surprising picture of our cosmic home. Situated between Mars and Jupiter is the asteroid belt, where millions of rocky celestial bodies orbit like a gigantic stone highway. Yet, this is not the farthest boundary. Beyond Neptune lies the Kuiper belt, an immense, frigid region filled with icy blocks, home to strange objects like Pluto and Haumea. The Kuiper belt is often likened to a reservoir for short-period comets. If the system ended there, the solar system would be plenty rich. However, scientists realized that what we know is still just the tip of the iceberg. Far beyond the Kuiper belt, a colossal, spherical shell is thought to envelop the entire solar system. That is the Oort Cloud. Picture it this way: if you regard the Kuiper belt as a fence around a garden, the Oort Cloud is the enormous, ancient rampart that encircles our home to the extent that it obscures the boundary between our cosmic backyard and the boundless interstellar space. It does not lie on the same tidy plane as the planets but surrounds the Sun from all sides, like a gigantic ice sphere. Intriguingly, despite never being directly observed, the cloud's existence provides a highly plausible explanation for many astronomical phenomena, particularly the origin of the peculiar long-period comets that appear unexpectedly and vanish, only to return tens of thousands, or even millions of years later. The story begins with the Dutch astronomer Jan Hendrik Oort and his peculiar hypothesis. When discussing the great minds of 20th century astronomy, Jan Oort's name must surely be mentioned. He was famous for his ability to read the sky using only numbers and observational data, not only helping to pinpoint our location in the Milky Way galaxy but also being among the first to find evidence for dark matter. In 1950, he astounded the scientific community by proposing a bold theory: the entire solar system is encased in a colossal icy shell. This idea was not arbitrary. Oort had spent years studying comets, those ephemeral visitors that appear and disappear into the darkness. He noted 2 main types: short-period comets, which return after decades or centuries, and long-period comets, which take millions of years to complete an orbit. It was the latter group that puzzled Oort. He observed that long-period comets exhibited strange characteristics. They did not follow a specific orbital plane like the planets or the asteroid belt. Instead, they seemed to arrive from all directions, as if originating from a sphere encompassing the Sun. More importantly, their aphelion, the farthest point in their orbit, appeared to cluster around a specific distance, about 50.000 astronomical units, from the Sun. In other words, there was an invisible wall at that distance, where billions of icy fragments lay waiting, occasionally being slung inward to become comets streaking across Earth's sky. From this, Oort conceived of the gigantic spherical cloud surrounding the entire solar system, which was later named after him, the Oort Cloud. Crucially, Oort never actually saw it. His hypothesis was based entirely on calculations and indirect clues. But in science, sometimes the logic of the data is strong enough to open up an entirely new field of research. The Oort Cloud became one of the most compelling ideas because it not only explained the origin of long-period comets but also revealed the blurry boundary between the solar system and interstellar space. If Oort's numbers were correct, this shell is truly massive, starting at around 2.00 astronomical units and stretching out to 100.00 astronomical units, equivalent to 1.5 light years. An icy cage we live inside but have never seen with our own eyes. In the cosmos, distances often defy our comprehension. For comparison, scientists devised a special unit of measure called the astronomical unit, O, corresponding to the distance from the Earth to the Sun, about 150 million kilometers. The Earth is at 1 astronomical unit, while Neptune, the farthest planet, is about 30 astronomical units. The Kuiper belt extends to about 50 astronomical units. These numbers, while seemingly vast, are just the doorstep compared to the Oort cloud. Calculations suggest the Oort shell begins at about 2.00 astronomical units and may extend to 100.00 astronomical units. Measured in light years, the fastest unit of travel in the universe, this thickness is equivalent to over 1.5 years for light to traverse. A more intuitive example is the journey of the Voyager 1 probe. Launched in 1977, the spacecraft has traveled for nearly half a century at a velocity of about 56.000 km per hour, yet, as of the 2025 update, it has only reached just over 165 astronomical units. It has officially entered interstellar space but is still far from the Oort cloud, meaning it is still at least 3 centuries of flight away from the inner edge of the Oort cloud. To fly through the entire cloud, humanity would have to wait approximately 30.00 years. This immense scale is also why we have not directly seen it. Unlike stars or planets that emit their own light, the icy fragments in the cloud only reflect a tiny amount of sunlight. At a distance of tens of thousands of O, that faint light is nothing more than a dim speck of dust in the darkness. Even with powerful telescopes like Hubble or the James Webb Space Telescope, JWST, direct observation remains almost impossible. This is because the Oort cloud does not emit its own light, and the amount of sunlight reflected is too weak for current technology to reliably record, especially for tiny, dark objects at such extreme distances. Thus, all our knowledge of the Oort cloud comes from indirect evidence, the peculiar orbits of long-period comets, computer simulations, and meticulous calculations. The Oort cloud remains a cosmic phantom, never fully materialized, yet leaving its traces in every movement around the Sun. Comets are truly the messengers from the Oort cloud. In human history, comets have always left a special impression. But to scientists, comets are like postcards sent from the most distant reaches of the solar system. The long-period comets are particularly strange. They arrive from different directions, disregarding the ecliptic plane, the plane of the planet's orbits. And it was these strange visitors that provided the crucial clue for Jan Oort's hypothesis. Each time a comet streaks toward the Sun, it heats up, vaporizes, and leaves a bright, elongated tail. Behind this spectacle, however, comets are memory capsules containing pristine material from the time the solar system was just forming. These icy, dusty blocks have remained virtually unchanged for billions of years, carrying invaluable information about the distant past. To understand why the Oort cloud exists, we must rewind time to 4.6 billion years ago when the solar system was newly formed. During that chaotic period, the gas giants, Jupiter, Saturn, Uranus, and Neptune, exerted a terrifying gravitational pull. Their gravity relentlessly hurled icy and rocky fragments outward. Some were thrown completely out of the solar system, vanishing permanently into interstellar space. But a portion was retained, swept up into distant, eccentric orbits, forming a loose shell around the entire solar system. Over time, this shell stabilized, becoming what we now call the Oort cloud. It is imagined as a vast natural storage region, preserving the primordial fragments from the epoch of creation. This is why many scientists believe the Oort cloud is like a living museum, storing the raw materials that once contributed to forming the planets, including Earth. Even more noteworthy, some comets from the Oort cloud carry water ice and organic compounds. One hypothesis suggests that when Earth was young, impacts from comets delivered the water and the first organic molecules to our blue planet. If true, the origin of life here may have begun with fragments lost on the far edge of the solar system. The immense Oort cloud is not always peaceful. Over billions of years, it has been occasionally disturbed by unwelcome visitors from beyond. Every star wandering through the galaxy has its own orbit, and sometimes a star inadvertently passes near the edge of the solar system. Just a slight gravitational nudge can dislodge masses of ice in the Oort Cloud, sending them hurtling toward the Sun as comets. A notable example is Schultz's star, which passed close to the outer region of the cloud about 70.00 years ago. Although its mass was small compared to the Sun, simulations show that some objects in the Oort Cloud were gravitationally affected, potentially becoming wandering comets. This raises a chilling question. What if a much larger star approaches the solar system in the future? A strong enough gravitational pull could turn the Oort Cloud into an arsenal, firing a massive barrage of comets inward. Earth and the other planets would face the risk of a relentless comet storm, possibly causing impacts large enough to alter the history of life. While the majority of astronomers believe the Oort Cloud actually exists, this doesn't mean there is absolute consensus. In fact, intense debates still surround it because we have never seen it directly. One group of skeptical scientists argues that attributing all long-period comets to a single gigantic ice reservoir tens of thousands of miles away might be too hasty. They propose that these comets could originate from outside the solar system, from interstellar space. This argument gained strength with the discovery of the first interstellar object, Oumuamua, in 2017, and the confirmation of the interstellar comet 2I, Borisov, in 2019, proving that tourist objects from outside the galaxy can pass through our skies. However, observational data accumulated over decades shows a consistency that is hard to dismiss. Many long-period comets have their aphelia clustered around 50.00 astronomical units, exactly as Oort predicted. Furthermore, mathematical models simulating the formation of the solar system indicate that when the gas giants hurled fragments outward, a portion of that debris must have been retained in distant orbits. Ultimately, most astronomers regard the Oort Cloud as the most plausible hypothesis currently available, even without direct proof. What if the Oort Cloud were to erupt? Until now, the Oort Cloud has quietly existed at the solar system's edge as a gigantic, unseen icy wall. But what if that wall were disturbed one day? In the worst-case scenario, a massive passing star or a sweeping molecular cloud in the galaxy could gravitationally destabilize millions of celestial bodies in the Oort Cloud. They would then become gigantic comets simultaneously hurtling toward the inner solar system. For Earth, this scenario is nothing short of a massive meteor shower. Many theories even suggest that past mass extinction events on Earth may have been linked, at least in part, to such disturbances from the Oort Cloud. Yet, seen from a different perspective, comets from the Oort Cloud are not just threats, they also carry water ice and organic compounds, the raw ingredients of life. It is possible that ancient impacts delivered the water and the first molecules, sowing the seeds of life on Earth. In other words, the Oort Cloud is both a potential menace and perhaps the midwife of the life we enjoy today. This strange duality forces us to view the Oort Cloud not merely as a dry astronomical structure but as an enigmatic entity, harboring an unpredictable power. Until that day comes, the Oort Cloud will continue to silently embrace the solar system in its invisible arms. The question will always linger: if it truly erupts one day, will we be ready to face the cold messages from that distant frontier? Comet.